Hello everyone. So in this video, I'm going to walk you through a couple of scripts that I have written to enable or use the memory store in Foundry agent service. Right? Microsoft Foundry is a service which allows you to create AI agents, model endpoints, and a lot of other things related to generative AI. And with their Foundry agent service, they recently added something new called as a memory store, right? And memory store is really powerful because it kind of enables a memory layer out of the box for the agents that you deploy in Foundry. Traditionally, doing something like this would have been more complex because you would have to set up something custom to kind of use services such as Redis Cache, MongoDB, Cosmos DB, or SQL if you prefer. But it will be way more complex. I think Foundry has made it really, really simple. So quickly to give you context, what is memory? Let's say you're interacting with another human. Let's say you meet a friend uh, over lunch and you tell your friend that you're allergic to peanuts, right? So whatever you kind of order, your friend will obviously ensure that none of that contains peanuts, especially if you're sharing something. And then a few weeks later, you go out for a team dinner, and I'm pretty sure that your friend would remember this particular interaction that you are allergic to peanuts. But agents cannot do that, right? Because every agent call that we make is stateless. So there is definitely no memory component embedded within an agent, and it has to be created manually. But with memory store, kind of takes care of that problem. So just to tell you this, if you look at this flowchart, the user is saying I'm allergic to dairy. Show me a recipe for cake. The agent responds saying that use oil instead of butter and a dairy-free milk substitute. But then it also makes a note of that particular memory or that particular interaction. Right? Few weeks later, when the user interacts with this agent again, and this is a completely new session, new conversation, and says that the user is saying, what are some good snacks for my party tomorrow? The agent can go back to that memory, remember that this user is allergic to dairy, and basis of that provide the response that some dairy-free snacks are fruits, hummus, and crackers. Right? We'll see how to work with memory in the following videos. Okay, now let's quickly look at the script to see what would happen if there was no agent memory, right? What I was talking about earlier, that every agent call is stateless. So this script just kind of initiates the AI project client. It creates an agent, um, then it uses an OpenAI client to do the large language model call via the agent, and then we create a conversation with a conversation ID. Then we create a agent response. So here the first input that we pass is, hi, my name is Saurabh. Uh, then the response is displayed. Uh, Post that, we wait for 10 seconds and then create a new conversation, right? And this time, for the new response, the input that we are going to pass is, what is my name, right? Now I'm going to run this, and what you would see is uh, the agent kind of acknowledges my name, right? So if you can see here, it says, hi Saurabh, it's great to meet you. How can I assist you today? Now we wait for 10 seconds and then we create a new conversation with the same agent, and then we ask, what is my name? And this time the agent says, I don't have access to personal information about you unless you explicitly provide it to me. So this is the problem that we are trying to solve, right? And the memory store makes it really, really simple. Okay, so going back to the documentation that Microsoft has provided, I think it's pretty detailed, but the scripts that I have written would really enable you to quickly understand how all of this is going to work. So all these code snippets are there already, but we have scripts written for each of these, which we will go through, right? So I have a GitHub repository where all the scripts are there. The link of this GitHub repo is there in the description. Please make sure you read the README file because there are some important things here. Firstly, the prerequisites. Obviously, you need a AI Microsoft subscription, and within the Microsoft subscription, you need a Microsoft Foundry service created, right? Within that Foundry service, there should be a project, and you should have a chat model and an embedding model deployed within your project, right? This is really, really important. So make sure that you follow the steps given here. So basically what this is saying is you need to have the right RBAC access to the AI Foundry resource where we are going to run these scripts against. And then the local set of instructions is something that we will go through in the video. So we don't need to read them here, but they are here in case you need to refer. So now we are going to get into some hands-on for people those are following along. Right, the first thing I would do is navigate to Visual Studio Code, and in Terminal I'm going to click on New Terminal. And now what I want to be able to do is navigate to a particular folder where I can download the files from the GitHub repository, right? For that, I can go to the file system, and here I'm going to create a new folder. I'm going to call this memory store. You can call it whatever you want, right? So this is the memory store, and I'm going to click right at the top. G drive is where I have created that specific folder. So I'm just going to copy this, navigate back to Visual Studio Code, and just type this command cd and then paste G. Once I do that, I should be able to find all the folders here, right? So I can just start typing as well, memory store, right? So this is the location that I want to navigate to. I'm going to hit enter. So now if you see, I am in G memory store. Next thing I would do is go to the GitHub repository that I have created, and in that repository, so the link is there in the description. Once you go to that link, you should be able to see this page, and at the top there would be code, and just click on this green button code, and you would see this repo URL here. So just copy this URL, go back to Visual Studio Code, and then type this command git clone, and then enter the URL that we just copied, and I'm going to hit enter. So what this would do is it's going to download all those files into your local system, and now they are available in this folder memory store, right? Once this is done, the next thing I will do is click on file and click open folder in Visual Studio Code. Navigate to that particular folder that we just created, which was memory store, which is right here. So I double click, and then you see the Azure Foundry memory agent folder inside that. Just click on that once and then click select folder. So what this would do is within your Visual Studio Code, you have now selected this as the parent folder, and now once you are at this step, just click on terminal again, new terminal, and this should show you that you are in the memory store Azure Foundry memory agent. So this is the right location. Right now we are currently using PowerShell. I prefer using Git Bash. I would recommend you do the same. So I'm just going to click on this down arrow and select Git Bash. So this brings me to the git bash repo, right? I have to confirm whether I am in the same folder. So I'm going to hit pwd and it shows that I am in the Foundry memory agent. Okay. Next thing I want to do is just click on this left pane, and then on my keyboard I'm going to hit the button Control Shift and P. This would give me an option saying Python create environment. If you don't find this, you can even search for it, right? But I'm going to click on Python create environment. You can either select Conda or Venv. I'm going to select Venv here. So I hit Venv. Then I have to select the interpreter path. So for me, it's Python 3.11.3. It could be something else for you. Make sure this has to be Python 3.8 or higher. So I'm going to select that. And then it's going to ask me if I want to install these dependencies, requirements.txt, which I do. So I'm just going to select that and then hit OK. Once I do that, it will take its time to create this virtual environment, and I'll see you once the dependencies are all installed. Okay, so all the dependencies are installed now, and you would know that by looking at this new folder that got created called .venv within the Azure Foundry Memory Agent folder, right? You can put a command like pip list to see if actually all the dependencies were installed. Not necessary, but you could do this. Now, very important step here is making sure that you are running the code through the virtual environment, right? And for that, you need to type this command source source and then just type .venv and it will show you that here. So click on that. Next, you have to start typing scripts. Again, you would see that. You could also hit tab on your keyboard to autocomplete and then AC, that's activate, and hit enter. So what that means is now you are in the right virtual environment, right? And actually, after you do this, run the command pip list so that it tells you that within this particular virtual environment, what are the packages that are installed, right? So all the packages that we need for this to run effectively should be showing up here. Okay, let me clear that. So now we are kind of set up to start running the scripts that are there within this repository. You can also access the README file here. So all the details are there within the README file, all the prerequisites, etc. Better way to look at this is just right click on the README file and click on Open Preview. Right, so it shows you a markdown version of the same file. Perfect. So next what we are going to do is make sure that the environment variables that are needed to run these scripts are updated. So you would see a sample.env file where you're expected to enter your existing AI project endpoint, your chat model deployment name, and the embedding model deployment name. Now these are prerequisites, right? But I'll quickly show you from where you will get these. Before that, right click on this file and rename the file to remove sample, right? So the file should be called .env only. This is what the file should be. And here is where we will enter our details, right? And let's find out how to do that. So navigate to Azure portal, open the Foundry service that you have created. Once you go to the Foundry service, in the overview tab itself, page itself, you should be able to see this go to Foundry portal button, right? So I'm going to click on that button and this should navigate me to the Foundry portal. Now, as part of prerequisites, obviously you should have a project created within the Foundry uh, portal itself. So my project is already here. It's called first project. Uh, so as soon as you click on that and come to this page, the first thing you should do is under the project endpoint, just copy this, navigate back to Visual Studio Code and replace the endpoint with this. So I'm going to put double inverted double colons, and then just put the link for my project, right? Next thing I would do is again go back to the Foundry portal, click on build at the top right, and then you should see this menu on the left. Click on models and then look at the chat model and the embedding model names, right? If you haven't deployed these, please do deploy them first. So I'm going to copy the GPT-4o model name here and paste it here. So this is the model name, and from for the embedding model, I'm going to copy text embedding 3 small and paste the name here. Make sure it's all in a single line, and my environment variables are successfully updated. Now that the environment variables are set correctly, the first thing we would do is go to the auth test.py file, and this will just make sure that you've updated all the environment variables correctly. So you should not be getting any error here. To run this file, I would go to the terminal and type python space and the file name auth test.py, hit enter, and this is the kind of output that you should see, right? Using default Azure credential, testing with listing memory stores, you should see this iterator object, and then authentication successful. That means everything is working as expected. All right, with that, we can get into the next script, which is creating the memory store, right? So I'll quickly walk through this script. You do a couple of imports that will be needed. So import os .env, and then from AI projects, import AI project client that will be used to initialize the client. From Azure AI projects models, import memory store default definition and memory store default options. So those will be used for creating the definition of the memory store and then the actual creation of the memory store. And then finally, you do the Azure.identity import default Azure credential. Right? Now, default Azure credential is not the recommended way for production applications. Please note that for production, generally you would use something like managed identity credential, where the user is actually not authenticating to your Azure resources, but rather it is a managed identity, which is basically a service account. So let's say you're doing the development on a virtual machine. That virtual machine will have its own managed identity, and that will be the one that is authenticating to the particular Foundry project resource, right? This is a demo, so that's fine. We are going to use default Azure credential here. So we do the load.env so that we can read from the env file for the variables. The first thing you do is initialize the client. So client equal to AI project client. Endpoint is what you pass, and then you read it from the .env file. Credential equal to default Azure credential. Right. Next, you provide the memory store options. Right. So here, basically, you use memory store default options, and in terms of chat summary and user profile, what are these, right? So let's go to the documentation for what is memory, right? And within that documentation you will find this memory types. So there are two types of memories that you can store. One is the user profile memory, which kind of saves information and preferences about the user, such as preferred name, dietary restrictions, language preference, etc. And these memories are static with respect to conversation because they generally don't depend on the current chat context. What that means is, irrespective of whether it's the same session or same conversation or different conversations or session, it won't matter. The agent will still have access to the user profile memory as long as it identifies that this is the same user that it is interacting with, right? Chat summary memory generally is a distilled summary of each topic or a thread covered in a chat session, and these would typically allow the user to continue conversations, but we have to be careful here whether we really need to store everything. So there might be some optimizations which I am yet to explore. So user profile memory is stored as user profile details, and chat summary memory is stored as chat summaries within the memory store. So if I go back to the code, you will see when I'm kind of creating these options, I can kind of put one of them true, both of them true, right, depending on my requirement. Another interesting thing is I can pass additional metadata for the memory store. So in this case, for user profile details, I've added another line that says avoid irrelevant or sensitive data such as age, financials, precise location, and credentials. So basically, the large language model within the memory store would identify that, okay, the user is clearly or explicitly mentioned in the option that please don't save sensitive information about the user in the user profile memory, right? Next, we create the memory store. So here the memory store needs two things, the chat model and the embedding model. If you remember, both of them, the names of which we have added in the .env file. And then options is equal to options. Finally, we create the memory store. Now name, I'm going to call this coffee assistant memory store. Let me use that name. Definition is equal to definition, and then I can give an additional description. So let's say memory store for coffee assistant agent. Hmm. So if this runs successfully, you'd see a message called created memory store, right? So let me run this. Python create memory store, hit enter, and then I get a message created memory store coffee assistant memory store. Just to show you that this is working, if I go back to my Foundry portal and open any agent, right? So these memory stores are created at the project level. So typically all agents existing or the ones that you create new should have access to that memory store. So if I just hit this drop down, you can see coffee assistant memory store is also available for this agent to use. Okay, now let's get into some interesting stuff. So this is basically just creation of memory store. Another boring script that I want to show you is quickly that how you can list the existing memories, right? So again, a very simple script. You initialize the client, you create a list called stores list, and then basically just call the client.memorystores.list function to get the list of all the existing memory stores that are there in your Foundry project, right? So here I'm just iterating through this particular list and printing them out. So very quickly, let's do Python list memory stores, Python underscore list memory stores. Oops, sorry, memory stores, and hit enter. And this should basically iterate through that entire list and then give you a very nice kind of output for each of those memory stores. So it found 12 memory stores and it's showing you the name, memory, and in this list, just note one thing that we can access any of these memory stores using the index number. So let's say I want to access the YT memory store, it's at index position 0, right? And that's how it would basically iterate through the entire list, right? Now, next, what we want to do is create a agent with a memory store, right? For that, we will go to the memory agent tool script. And again, let's quickly walk through this. So standard imports that we do, just one or two additional ones, which is the memory search tool and the prompt agent definition that will be needed for the script. So again, standard stuff, initialize the client. Now scope is really, really important because how scope works is it kind of acts as the user profile um, metadata to associate a particular memory, right? So let me just quickly go back to the portal And if you see under my agent in the memory section, there are two things. One is the memory store, and then other one is the scope, right? So scope is something that will be needed to tag that particular uh, memory store so that the memory store or the agent within the memory store, which is the chat model, is able to identify which user they are interacting with, right? Which helps in searching. So scope has couple of rules. I think you can only have alphanumeric characters. You cannot have underscores. I think hyphens are allowed, right? So the scope again we will create via the script. So in this case, I'm gonna call the scope coffee user, right? Let me call this, and let me use camel case actually instead of uh, the hyphen. So this is my scope. Next, I will kind of list everything, and this is needed because I just want to check that whatever the user is passing as the name for the memory store, whether that already exists. Now, what we want to do is use the memory store that we just created, which is the coffee assistant memory store. So in place of this, I'm gonna rename my store to coffee assistant memory store. So basically when I put this, it's going to go through this list, identify that memory already exists, and it's going to print using memory store coffee assistant memory store. Post that, it's going to create the memory search tool, right? So tool equal to memory search tool. Here we pass the memory store name, the scope that we defined earlier, and then this is just a delay for the memory to update, right? Next, we create a prompt agent. So client.agents.create version, agent name. So let me call this my coffee assistant agent with hyphens. I think here also the similar rule exists that the name must start and end with alphanumeric characters and it can contain hyphens in the middle and must not exceed 63 characters. Next, I give the definition, which is the prompt agent definition. So here I pass the model, the instructions, and then I give access to the tool, the memory search tool that I created. If this runs successfully, we should see a message saying agent created with the metadata for that agent. So let's see, Python memory agent tool, and then hit enter. Right, so what it says is using memory store coffee assistant memory store, which we created in the earlier script, and then the agent is created. It has this ID, this is the version, this is the name, and then again it says version 1. If we go back to my Foundry portal, you should be able to see the coffee assistant agent that we just created. The scope is coffee user, the memory that it is using is coffee assistant memory store. Okay, so now let's see all of this in action with the next script, which is the memory enabled agent.py, right? So again, standard libraries that we import, load.env, initialize the client, get the memory store name from the user. So this is just one additional step that I have added where the user can input the name of the memory store. If that memory store exists, obviously that one will be used, and if not, then a new memory store will be created with the configuration provided you, right? Next, again, we create the memory search tool. uh, Remember, we passed the scope for user. Now we have to make sure we use the same scope in this script. So I'm just going to go back and select the scope, which is, I realize I have misspelled coffee, but that's fine. So I'm just going to put this scope here, coffee user, memory search tool, and then you basically pass, the name of the store, the scope, and the update delay. Right? Now, again, in terms of agent, you could either create a new agent here by providing the name, and if that agent already exists, it's going to use the same agent name. So in this case, again, we are going to be using the coffee assistant agent. So let me copy that and let's paste that as the agent name, right? So then it's going to basically go through this to understand if the agent already exists. If it does, then it will use the same agent. If not, it's going to create a new agent for us, right? Next, we use the OpenAI library. So we create this OpenAI client, client.get OpenAI client, and then we create a conversation, right? So that we can print the conversation ID. And I just want to show you the printout or print of the conversation ID so that you realize that the script is actually going to create two conversation IDs, but then the agent would still be able to remember the earlier conversation that it had. Okay, so first basically we create this response, and here the input that I'm going to say is I prefer dark roast coffee, right? And then print out the response from the agent. Then let's wait 10 seconds and we'll pass or create the next conversation. So the new conversation ID will be printed and the new response, the input I'm going to pass, please order my usual coffee. So note that these two are completely different sessions with different conversation IDs, right? And then we will print out the response from the same agent again. So let's run this Python memory enabled agent.py, and let's run this. So it's asking me for the name. I have to be careful that I pass the same name that I used earlier. I'm just going to copy it from here. Yeah, so this is coffee assistant. Let's paste that, hit enter. So it says using existing memory, using existing agent, and then it's going to print out the first response. So note that this conversation ID is created. The agent response saying dark roast coffee is great choice, blah 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 blah. Now we wait for 10 seconds before creating a new thread or a new conversation. So this is a completely different conversation ID, and the response is sure, ordering your usual dark roast coffee, right? Now there is a way we can inspect or have that observability feature on Foundry itself, right? So let's have a look at that. So I am within the coffee assistant agent, and if I go to traces, just to show you what is happening under the hood, right? So this was the first conversation that we had, and if I go and inspect this, here you should be able to see this information being passed. I think it's still loading. Just give it a couple of seconds. Yeah, just maybe I'll come back once the loading is done. Okay, so it's loaded now, and first let's see what is the user input. I prefer dark roast coffee, and the agent output is right here, right? So there are two steps. One is the message and the memory search call. So this is the message, and in memory search call, if you see, because this is the first interaction that we are having, you can see that there is a list called memories, but it is empty right now. Okay. Next, I will go to the second conversation that we had. And in the second conversation, let's say, okay, the user input was please order my usual coffee. And the agent kind of knows that dark roast coffee is my regular or my favorite coffee. If I go to the memory search call, this time within memories list, you should be able to see the content user prefers dark roast coffee. So this is basically a summarization or a note that the agent has taken from the first interaction that I had. If you see the kind, it is user profile, right? It has a memory ID, it has a scope, very important, and when it was updated, right? It basically has additional content there, and this is the chat summary part. So there are two types, user profile and chat summary. So both these get stored because if you remember when we created the memory store, we put both as true, and basis of that, this entire thing is able to work. Perfect. So now I hope you have been following along. In case you are running into issues, please feel free to put them in comments and I'll have a look at this. The last part, what we're going to do is create a memory chat app. So we are going to create a Streamlit application where you can interact with the agent, have long conversations, and I'll also show you how all of that is working in the background, right? So again, this is a pretty standard script for Streamlit. We have all the same imports that we will be needing. Load.env, and then basically we do the page config first for the Streamlit UI. We initialize the session state with couple of things. So because within that particular session, we need to know the conversation, the agent that we are interacting with, the OpenAI client, chat history, as well as the memory store, right? So all of this would happen. So there is a configuration button on the sidebar, which you will see once we run the script, where I can select or rather input the memory store, right? And if the memory store exists, it's going to use the same memory store. If not, it will create a new one. The configuration also has a agent configuration. Again, same, you provide the agent name. If the agent exists, it will use the existing agent. If not, it will create a new agent, right? So this is the agent part. Then you have the main chat interface where there is a chat button. So the user can provide his input. That input is going to be passed here. And once the input is provided, a couple of things will happen. So one is it will send that input to the agent so that the agent can respond. Plus, we will also have chat history on the UI, right? The assistant message will get displayed here, add to history step happens here, and there is some information on the sidebar. So the session info will also be shown within the sidebar. Finally, there is a clear chat button as well, right? So now, in order to run your Streamlit app, this is the command. It's not the regular command where you say Python and the name of the file, but rather you say Streamlit run, and then you get the name of the app. So this is memory chat app. Let's hit enter, and that should bring up this UI of Streamlit. Now I want to enter my memory store name first, right? So I know that the memory store that we are using for this particular agent is called coffee dash assistant dash memory dash store. So let me put that name, coffee dash assistant dash memory dash store, and just double checking that's the name, coffee assistant memory store, and then load the store, memory store. So basically it's using the existing one. The agent name that I have provided is coffee assistant agent. So again, I'm going to just put that name here and hit initialize agent. So now it is updating the existing agent, coffee assistant agent. This is the session info that you can see. So conversation ID is also shown. Messages are 0 currently. And now I'm gonna say, hi, I have lower back pain. And that's it. That's all that I'm gonna say, right? So I'm just telling the agent that I have lower back pain, and typically the agent is going to do two things. One is going to respond to my uh, prompt, but then also store this summary somewhere within the memory store, right? So the next question I'm going to say is, I am planning a hike at a nearby hiking location. Please give me some tips. And what I expect the agent to do is go to the memory store, search that I have a lower back pain, and tailor the response based on that memory that it has. Right? So that sounds like an exciting adventure. Hiking is a great way. Since you mentioned lower back pain earlier, I'll tailor the tips to ensure you have a safe and enjoyable hike, right? So it basically gives you before the hike, during the hike, after the hike, etc., etc. So all of this is kind of working, and let's see the traces. It takes sometimes a couple of seconds or sometimes a minute for the traces to show up. Yeah, so there you are now, right? So if you see the conversation ID is the same, right? Because within that chat session, we are kind of maintaining the session and ensuring that it is a single interaction. Now, if I go to the latest one, this is going to be like a thread of messages, right? So the first memory search call is going to be having certain memories here. So user prefers dark roast coffee. This is the earlier conversation that we had, right? So this is nothing to do with what we entered on Streamlit, but via code, if you remember, we had passed this information. Hence, it still remembers that, right? In the next memory search call, there will be additional memories. This time, the dark roast coffee exists, but then also user is experiencing lower back pain, right? And actually, let me show you this. So just because this agent has my earlier memories, if I just say, please order my usual coffee, right? It should have access to that within the memory store. It's a completely unrelated question, but because of that, it's able to tell me, since you enjoy dark roast coffee, would you like me to order it for delivery or recommend a nearby coffee shop, right? So this is the kind of beauty of this agentic memory. Um, I hope this video was helpful. If you liked it, please do like the video and please do share your comments as well. Thank you so much.